Hello and welcome to today's class. We are going to look at inverse of 2 by 2 matrices. All right. So basically, I hope that by now you know what the term inverse means. Inverse simply means reciprocal of a number. It could be reciprocal of a number or a matrix. So therefore, an example, let's say, of an inverse would be, let's say you're given the number 2. The inverse of 2 would be a half. If you're given the number 3, the inverse of 3 would be a third. All right. So basically, that is what an inverse is. It's a reciprocal. So in this particular class, we're going to look at reciprocals of matrices. All right. So assuming you are given a matrix with the elements A, B, C, and D. And okay, so this matrix is labeled A. All right, and this matrix is labeled A. Its inverse, sorry, which is A raised to negative 1. All right, its inverse, which is A raised to negative 1, will be given by the reciprocal of the determinant. So that will be 1 all over. How do we calculate the determinant? Multiplying elements of the main diagonal. So it will be 1 all over AD minus elements of the other diagonal, that is CD. The product of that's going to be C times D. So we will find the inverse, that is A raised to negative 1, by multiplying the reciprocal of the determinant. And that is why the class on determinant was very important. Then after we've done that, we will interchange the elements in the main diagonal. So in the matrix A, we are having A and D, all right, in the main diagonal. So where we have A, we'll put D. Where we have D, we'll put A. So basically, instead of having AD, we're going to have DA. So we will have D come in place of A and A come in place of D. Okay, then finally, to get the inverse, we will negate the elements in the other diagonal. So if whatever elements we have in the other diagonal, we will multiply by negative 1. All right, so this will be C multiplied by negative 1 with negative C, and so B multiplied by negative 1 will be negative B. And so this here is what will count as the inverse of the matrix A. So let us do an example and see what this actually means. All right, so we have an example here. We are supposed to find the inverse of the matrix we've been given below. So the matrix is over to order 2 by 2, 2, 4, 3, 5. All right, so for us to find the inverse of this particular matrix, which apparently is matrix A, all right, so for us to find A inverse, that is A raised to negative 1, we are going to have to multiply the matrix by the reciprocal of the determinant. And so the determinant in this particular case will be 5 times 2, or 2 times 5, all right? Okay, so that's going to be 10 minus 3 times 4. 3 times 4 is going to be 12. We interchange the elements in the main diagonal. So where we have 2, we'll have 5, and where we have 5, we'll have 2. So it's going to be 5, and it's going to be 2 right here. And then we will, for the final step, negate the elements in the other diagonal. So basically that means that we multiply each of those elements by negative 1. So it's going to be 3 times negative 1, that's going to be negative 3, and 4 times negative 1, which is going to be negative 4. All right, so this will simplify to 1 all over 10 minus 12 will be negative 2. So, but that is basically negative half into 5, negative 3, negative 4, and 2. All right, so at that particular juncture, we can leave our answer at this point, or go ahead and multiply this matrix by negative half, which is basically scalar multiplication, as we already know. But for the sake of this class, I'll just leave my answer at this particular point. So this here will be the inverse of this particular matrix. So for the last example, I want to introduce you to a new concept, while tackling this last example, and that is the concept of what a singular matrix is. All right. So what is a singular matrix? All right. That is what we want to find out. All right. So let us try and actually solve this particular problem as we understand the concept of a singular matrix. So we are having the matrix 3, -9 right here, -2 and 6. All right, -2 and 6. So remember, and this matrix is actually labeled B. All right. So remember, for us to find the inverse of B, all right, that is b raised to -1, we're going to have to multiply it by the reciprocal. All right, multiply it by the reciprocal of the determinant. So that's going to be 1 all over, that is going to be 3 times 6, that is going to be 18, minus -9 times -2, that is going to be 18 as well. All right, so into we then go ahead and interchange the elements in the main diagonal. So where we have 3, we'll have 6. Where we have 6, we'll have 3. So it's going to be 6 and 3 here, and negate the elements of the other diagonal. All right, so notice we are going to negate the elements of the other diagonal, and so that's going to be -9 times -1, that's going to be 9, and -2 times -1, which is going to be 2. All right, so let's go ahead and simplify whatever we are having in the determinant, right outside the matrix there. So it's going to be 1 all over 18 minus 18 is 0. All right, into 6, 9, 2, 3. Now there is a special case here. Whenever we have that the determinant is equal to 0, we say that the inverse of that matrix does not exist. Why? Because we cannot divide any number by 0. Okay, we cannot divide any number by 0. And so whenever we have that our determinant is equal to 0, we always then say that in this particular case we say that B has no inverse. B has no inverse. And so whenever you have a situation where a matrix has no inverse, we say that that matrix is a singular matrix. All right, so that is what I wanted to introduce you to, the concept of singular and non-singular matrix. So a singular matrix, in other words, is any matrix that has no inverse. Anytime you have a matrix that does not have an inverse, we describe that matrix as a singular matrix. And those are usually matrices whose determinant is equal to 0. Okay, they're usually matrices whose determinants are equal to 0. Why? Because no number in the whole world can ever be divided by 0, and so we cannot find the determinant of this matrix as we are getting that it's we are supposed to take 1 divided by 0, and as mathematically that is not possible. All right, so that is what a singular matrix is. It's a matrix without an inverse, and a matrix that has an inverse on the other end is called a non-singular matrix. Non-singular matrix. So for example, in the first example we handled, this here is a non-singular matrix. So that is it for today's class. Go ahead and have a wonderful week ahead of you.